Okay, so anyway, tangent is going to be positive in the first quadrant and the third quadrant because it's based on y and x. So the tangent thing looks like this, positive, positive. So just to review, where was sine positive?
Top.
And cosine,
Right.
right? Alright, so we're throwing this guy in, and not just tangent, we're not just doing tangent. We are doing all the reciprocal functions, which you guys probably forgot what that meant, but so the base functions are the SOHCAHTOA. Sine is opposite over adjacent, you know, all that stuff. But there was cosine, whoops, opposite over hypotenuse, my bad. Adjacent over hypotenuse. Opposite over adjacent. But then each of these had a reciprocal function. Do you guys remember these? What was sine? It's called cosecant. Cosecant. So cosecant would be hypotenuse over opposite. And yeah, secant was the reciprocal just means flip, right? So you could say this equals opposite over hypotenuse, this equals hypotenuse over opposite. You could also say that sine is equal to 1 over cosecant, or you could say the same thing in reverse. Cosecant is 1 over sine. Because the cosecant button is not on the calculator, so we have to plug in like 1 over sine. You guys remember doing that? So secant is the reciprocal of cosine, and what's the reciprocal of tangent? Cotangent. So these two kind of match, right? The tangent, cotangent. These two I kind of remember them because they don't match. They're opposite. Because this is cosine and cosecant. They don't go together actually. Okay, so since we're on the like in the unit circle and all right, since sine is based over like y over r, that's what sine is equal to. Cosecant is like r over y. So where is cosine going to be positive? The r value is always considered to be positive. So it's still based on the y value. So in other words, where sine is positive, cosecant is positive. Or, I didn't mean to do that. So this is not working.
It's selected, so you have to unselect it.
Okay. I used to be able to do that.
And it would bounce on the side.
Okay, yeah, it would bounce around. I used to put up like a hook right here and then make a bowl. And then you could like try and shoot it. Doesn't slide anymore as much as it used to. The old smartboard was better in some ways. Okay, so cosecant is going to be positive where sine is positive. And secant's going to be positive where cosine is positive. And cotangent is positive where tangent is positive. So, I don't know, do I need to write them all out? Secant is kind of based off of cosine, so it'll be positive here. And cotangent is based off of tangent, so it'll be positive first and next.
Since cosecant is the opposite of sine, why isn't it like the positive and negative flip?
Okay, it's not really the opposite, it's the reciprocal. So, whereas sine is equal to y over r, this is equal to r over y. And the r value is always positive, so it just depends on whether the y value is positive or not.
Okay.
It's kind of the same with all these. So this would be r over x, x over r. And this would be x over y instead of y over x.
Okay.
So it turns out they're just positive in the same place. Alright, let's jump in. Alright, number one, these are calculator problems. They're a little bit different because, like, B says cotangent. So, number one, you can just plug in tangent of 100. It says around to 4 digits, just like we did yesterday. It says 100 degrees, so the calculator should be in degrees right now. What do we get?
Negative 5.671.
Negative 5.671. No, wait.
You said fourth decimal.
Oh, no. Okay, I said it wrong. It says four significant digits, which means you just put the first 4 digits. First 4 non-zero digits. So, yeah. Have we never done that before, maybe? 4 significant digits just means, just round it to the 4th. So it could be 4 decimal places. It could be 5 decimal places if the first decimal is a 0. Okay, so you round it to the 4th non-zero digit, basically. Unless 0's in the middle, that still is 4. It would still be 4 decimals. Okay. 4 significant digits. B, cotangent. So what are we going to plug in the calculator if it's cotangent? No, that's something else. 1 over tangent. Yeah, we are going to do the -1 thing later. You guys remember what tangent inverse does? You feed it, normally what a normal tangent does is you feed it the angle, I don't know, 30 degrees or whatever, and it'll spit out a ratio. What would 30 degrees be? It would be square root of 3 over 3, or a decimal or something. But with tangent inverse, you feed it the ratio, and it spits out the angle. Okay, anyway, we're not doing that right now, but I wonder, is that the next one? Should be it. Yeah, that's actually tomorrow's. Okay, what do we get for B? So you plug in 1 over tangent, if it says cotangent, of 276. -1.1051. Yeah. 1051, yeah, that's right. C is cosecant. Cosecant is 1 over sine.
Didn't you switch it to radian?
Yes. Since it says 5, not 5 degrees, it's 1 over sine of 5 radians. Yes, we do need to switch it. Let that one spit out.
-1.042.
Which rounds up to 3. Still rounding. Secant is 1 over cosine.
Did you check the radians? No, in degrees. That's probably why.
If it doesn't say degrees, Leo, like on C and D, on 1 and 2, that means it's radians.
Okay.
Also, the numbers are usually smaller when it's radians, because and we all figured out how to change our calculators yesterday, right? Okay, number 3 is kind of what we were doing yesterday with the reference angles. So 3a says sine of 195. So what quadrant is 195 in?
3.
Right. Remember this is 180, so 195 must be in the third quadrant. And the reference angle basically is how far is it from the x-axis? So 15 degrees. So it's going to equal sine of 15 degrees, but then you got to say is sine positive or negative in the third quadrant? Negative. So okay, B is secant of 280. Where is 280 at?
4.
4. There's 270, so 280 is barely into the fourth quadrant. So the reference angle though is how far is it away from the x-axis, which is 360. It's 80 degrees away from the x-axis. So it's, all right, secant is based off of cosine. Is cosine positive or negative over here? Positive. So it's going to be positive secant of 80 degrees. Any questions on that? Anybody wants to admit to? C. Tangent of negative 140. So what quadrant would that be? If we're going backwards, this would be negative 90. This would be still 180, but negative 180. So 140 is, in the third quadrant. How far is it away from 180? 40. Is tangent positive or negative in the third quadrant?
Positive.
Positive. So it would be positive tangent of 40. D. Uh-oh. Trouble. Emergency. Secant of 2. Where the heck is 2? Okay, you might want to put this note at your top also. So in radians, this is 0. What's this in radians? Pi. Or if we're not writing it in terms of pi, it's 3.14. What would this be in terms of radians? 1.57. Okay, so that kind of replaces the pi over 2 or 90 degrees. And this one would be like kind of these two added together because it's like another 90. So it'd be 71. This would also be like 2 pi or 2 times that. So it'd be 6.28. Of course it keeps going. If it's over 6.28, you need to subtract 6.28. I don't think they're going to do that to us. I don't believe. No. So we don't have to worry about that trick. It's like when we subtract 2 pi because the angle is, or 360 when the angle's too big. Okay, number 5. Speaking of large, we're on the D, never mind. Secant of 2. So where would 2 radians be? What quadrant? Second. Somewhere in here. Doesn't really matter. But the reference angle is going to be how far is it away from?
1.14.
Yeah, 1.14. 3.14 minus 2 is going to be 1.14 radians off. So this is secant we're talking about. Secant is based off of cosine. Is cosine positive or negative in the second quadrant? Negative. We probably shouldn't turn the radio on in the morning. I just get some song stuck in my head. You don't want to be an Allison. Just kidding. Kind of. Okay, number 5 is 820. Yeah, let's not put that there. Alright, the angle's too big, so how do we shrink it down to like a...
Well, or minus 7.
Or minus 720 if you're a little bit more advanced.
Why don't you shut the frick up?
Have you been looking at the back
Yeah.
of the book, Trey?
No.
Pretty
That's
sure
a
you
good
would.
idea.
Why would you look it up in the back when it's right on the board in front of you?
I was gonna say.
Okay, anyways, yeah, you'd have to do a couple 360s away from that. That's just,
Stupid.
it is a little bit too big. So that comes down to a 100-degree angle. What quadrant is 100 degrees in? There's 90, so it's just a little bit into the second quadrant. And the reference angle, how far is that from 180? 80. So it's going to be tangent of 80 is tangent positive or negative in the second quadrant. Negative. Okay, B, secant of 290. What quadrant is 290 in?
4.
It's a little bit into the fourth quadrant. How far short of it is, how far short is it from 360? So that'd be a 70-degree gap there, so that would be the reference angle. So it's secant of 70. This is a cosine function, so is cosine positive or negative? Right?
Positive.
Positive, so the bigger one. Okay, C, 185. What quadrant? Cotangent 185, right? Okay, what quadrant is cotangent in? Or sorry, 185 in? 3. How far away is it from 180? 5. Is tangent and cotangent positive or negative in the third quadrant? Positive. So I'm just going to leave that 5 degrees. You're right. Cosecant of 4. What quadrant is 4? And I'll go back up here. In radians. There's 4.71. So it must be around there somewhere. So how far is it from the x-axis? 4 minus 3.14. Be 0.86. Are we in cosecant? 0.86. Cosecant is based off of sine. Is sine positive or negative in the third quadrant? Negative.
Yeah, Mr. Jordan.
Hmm.
Why isn't it 0.71 since it's 4? And
Because it's how far is it from the x-axis? How far is it from 3.14?
Okay.
So we did 4 minus that. Alright. Number 7, everybody's favorite. That might help you with both of these. Okay, so where is cosecant undefined at? Well, cosecant is the opposite of sine, so instead of being like y over r, it's r over y. So where is this value going to be undefined? What makes this not work?
Bottom's negative or square
No,
root?
you can't divide by 0. So where in the unit circle is y equal to 0 at? Where's y equal to 0 if we go around like this? In the middle here. Y goes up and down, so it's 0 in the middle. So at, oh, they did. It's 0 when the angle's 0, when the angle pi, when the angle's 2 pi, when the angle's 3 pi. It keeps going around. So every pi, so they just put in pi. Hmm?
That's when you get us confused.
No, I perfectly understand that.
Just claim it and pray you don't get asked a question.
Ask it the next one. No, I'm good.
It's alright, this is confusing.
We're just staring at the board.
Okay, B
I definitely understand.
B is where is the value equal to 0 at? Well, for this to equal 0, the radius would need to equal 0, right? And the radius is never equal to 0, it's always 1, so it can't,
No solution.
yeah, this is none. Big, really big difference. You want to explain what that difference is?
No, I have a headache right now. I'll worry about it later. It's just wrong.
Okay, where is the value equal to 1? So if the radius always equals 1,
And everywhere?
we basically need to know where y is equal to 1, and this ratio would equal 1. So where is the y value equal to 1 at on this top? And what, in radians, what's the degree right here? What's the radians? Well, yeah, pi, this is pi over 2. And then, of course, every time it goes around, it'll get back to 1 again. So pi over 2 plus 2 pi n. So d is -1. So if y equals -1, the whole thing's going to equal -1. So where's y equal -1 at? And what's this in radians? 3 pi over 2. So it'll be 3 pi over 2 plus every revolution thereafter. Okay. It's okay if you don't fully get these. You do need to know how to do the rest of them. I'm going to help you guys with 8 too. Because, well, anyways. Cotangent. That's what we're doing now. So cotangent is based on x over y, basically. Cotangent of the angle equals x over y. So when will this be undefined? Well, whenever y is 0, this will be undefined. So it's pretty much the same thing as this one. Whenever y is 0, it's not going to work. So where are the y values 0? Remember we talked about that, like 0 pi, 2 pi, 3 pi. So every pi, so pi n. Okay, b, where is the function going to equal 0? Well, for this to equal 0, what has to happen over here? No, just x. 0 divided by anything is 0. So where does x equal 0 at in the unit circle? Where's x equal 0 at? X is right and left. So where is it 0 at?
Middle.
Yeah, at the top and bottom basically. It's got a 0 for the x value.
So
So what's this in
pi.
pi over 2?
And
This is 3 pi over 2, but basically you add pi, add pi, add pi. So it's pi over 2 plus pi n times. Okay, C is 1. For this to equal 1, we need the x and y value to be the same. So when will the x and y values be the same? Something divided. Okay, when you have like a perfect diagonal, basically, this value and this value are going to be the same. So what's this angle right here? 45. What is 45 degrees in radians? Well, it takes 1, 2, 3, yes, it takes 4 of them to get to pi. So this is like 1/4 pi. So it's pi over 4. It would also work down here though, x and y would be negative something. So you just keep adding pi to that. And you keep getting answers. So plus pi.
Are we on chapel schedule today?
Oof, we're about out of time.
Yeah.
And D, where is it going to equal -1? So it'll equal -1. Basically, cotangent or cotangent is negative in these quadrants. So instead of 45, it's like 45 short of 180. So it's like 3/4 pi plus pi plus pi. I must like getting Lydia downstairs because I always ask for it, don't
It's great to be downstairs.
I? No.
Great to jump on yesterday. Great, I like spacey running fronts.
It's kind of the other way around with me and Grant.
Why? Why is the other way?
I give him downstairs.
After reports.
No.
Well, mostly he's just loud.
He is loud. He farted yesterday.
But yeah, he does fart. Even the boys are starting to ignore him now, though.
Good. They should. He farted the day in the car right before he left to
Yeah,
go to school, and I was not appreciative.
you didn't appreciate it.
I don't check for your
Okay. Well, I do want to do 13.
I think it's a 2 days.
No, it's definitely not a 2-day assignment.
what? It's not.
Oh no, we'll do it tomorrow.
Okay.
2 days time.
No, it's not a 2-day assignment.
Oh, you said the word.
I said not 2-day assignment. That's what I said.
This is a 2 day assignment.
It's
You know it.
Wednesday, so it's just doing Friday anyway, right?
You know it.